So what I'm going to do is I'm actually going to quickly now show you how I would do it. So let's just get back to this original solution, which was balanced. And I'm going to create a copy of this. Okay, so what I would do is I would create 2 new columns. Well, actually, we'll just create one, and I'll call this binary, the binary production. Whether we produce yes or no. So here this would be 1 because we produce, and 0 and 1. And basically I would put a constraint to actually say that we can't actually produce if we don't have the binary production. And what I will actually do is I'll actually say I'll have one I'll call it a big M constraint. And what we're going to do here is it's going to be 1,000 times these variables. And basically it will say, I mean, we could have set this as 600, but generally we just set an arbitrary big number. In this case, we're never going to produce more than 1,000 in this model. Let's just write this. And so what we can do, and then the cost, is basically the sum product here, plus it's going to be the fixed costs times by the actual production. So that just basically has done what we did here, but it's actually included it into a nonlinear program. And now let's do the solver. So, okay, so we have a nonlinear solver. We could actually use the simplex here, but do it as an integer simplex. So we're going to minimize this, subject to our kind of standard balance constraints. So, sorry. So we're going to set all of these, and now we'll add our constraints. So we'll just start off with the balance constraints. We also have the constraints that are production constraints. So the production is less than or equal to our big M production. And then finally, these guys are going to be integers. Now they're actually going to be binary integers. Okay, so that's my new little model. We're going to do it as a mixed integer program, as we did earlier in the chapter, and I'm going to solve it. And there we go. We lose $20, and we do this, and we actually only produce in the first period. So that's the optimal model. So honestly, that's much better than using the evolutionary solver. So that's kind of my method of doing it. And again, it's just being intelligent with being able to use binary variables to replace these terms with basically binary variables multiplied by the fixed cost, and then using what I call the big M constraint, which is basically 1,000 times my boundary variable, to enforce that we can only have production if we have a binary production variable.